Hello. You should see. Can you hear me now? Does everything seem okay?
Yes, Professor.
Okay, great. Let me. And okay. Okay. Today we're going to start looking at a couple of new ideas in languages. We're going to introduce two more languages, languages 4 and 5. And the last language we did, the one your homework assignment is about global variables. Okay, so the variables are just global. Now we're going to start adding scope to variables. We're going to have local and global variables. Oh, I misspelled global. Okay, so we're going to have local and global variables. Okay, so let me download these two languages. I don't know if we'll get to talk about both of them today. Okay. Well, actually, I should download language 3 because it'd be useful to compare the languages. So let me just go ahead and download language 3. Okay, language 3, 4, and 5. Okay, so language 3 had this syntax. Okay, and the thing that was new in this language was the ability to declare a variable, and all the variables are global. Okay. And there we said we actually used var for two purposes, to both declare a variable and to set a variable. So if you declare, if you look at some example programs. Well, actually, let me just run the interpreter. Oops. Okay. If I say var x 0, I create a variable x. Okay. If I say var x1, I'm changing x. So I change the variable x from 0 to 1. So var x is both creating a variable and updating a variable. Okay. So if I say var y1, I get a second variable. And if I say var y -1, now I'm changing the value of y. Okay. Right. So var acts both to create a variable and to update it. So it's both a declaration and an assignment. Okay, so that's language 3. And there's just one level. All the variables are in one environment. There's just this one global environment holds all our variables. Okay, now we want to add nesting to our language, scopes. Okay, so language 4 changes. Language 4, there's still var, but there's also something called begin. Begin is like an open and close brace. You begin a block. So where in the Java language, you're used to doing things like this. You have a brace, and then you can declare a variable, int x equals 0, int y equal 1. Okay, and then you can close that brace, that block, and then you can declare another variable, int x equal 5, and that's a different x. And if you go up here in Java, or C, if you say int x equal, say, 10, this x hides that x, but then here you can't redeclare x, so then here you would say x equal 5. This x is that x. This x is a new x. That's a local x. Okay, that x is local to that block. Okay, and if this is really Java, everything's in a block. So we would be in some other block here. Yeah, everything is going to be in some block. Okay, so this x is local to this block. This x is local to this block. This x is back, this x here is back to this one up here. And this one goes out of scope. See, this x ceases to exist when we get there. You know, its scope is up to that brace. So this x lives up to there. So I could say y equals x plus 1 because x is in scope there. Okay, so x lives up to there. Notice I can't say x equals y because there is no y yet. Y lives from here to there. So that y does not exist. On the other hand, if I do this, this y lives all the way up to here. Okay, he's overridden by this y from here to here, but at this point, the y that's in scope is that one. Okay, at this line here, that y is in scope. Starting here, this y hides that y. Okay, this, oh, and starting here, this x hides that x. So this x is this one. Okay, so this x starts to hide that x. So this x is that one because this one's in scope up to here. Then this x is back to being this one here. Okay, so those are scope rules. Okay, that's, now here I'm describing Java scope rules. Java, Python, JavaScript, C++, C, they all have slightly different scope rules. Actually, the rules I'm describing here are not Java. I'm sorry, these are not Java scope rules. What I'm doing here is C++ scope rules. So I'm actually doing C++ here, not Java. Okay. Does anybody know the mistake that this is? Does anybody know where Java would complain about this? This would be legitimate in C++, but Java would complain about one thing. In Java, a local variable can't hide another local variable. You can't have a local variable that hides a local variable. I can show you. Let's go to the Java visualizer real quick. Okay. Int x equals 0. Okay. Brace int x equals 0. Okay. See, notice the error message. Variable x is already defined. Okay, you can't have one local variable hide another one. Okay, on the other hand, let's try C. So let's try C. Here's the C visualizer. Okay, so I'll do int x equal 0, brace int x equals 0. Okay, notice I'm doing the exact same thing in C as I did in Java. Declare a local variable. It's local to main. So I'm declaring a variable local to main, declare a local variable, and then try to hide it. C, declare a local variable, then try to hide it. The C visualizer is slow. See, it's fine. Notice I got two X's. See, I've got an X on line 5 and an X on line 3. When I get to line 5, this X is hidden by that X. So I have actually two X's, but only one of them is, they're both in scope. When I'm at line 5, they're both in scope, but one hides the other. Now, the Java people thought that was a bad idea, so they outlawed that. A local variable can't hide another local variable. A local variable can hide an instance variable. A local variable can hide, instance variables and static variables, but a local variable can't hide a local variable. Okay. But in C, local variables can hide local variables. And Java thought that's probably flaky. If you're doing something like this, you're probably making a mistake or not thinking very clearly. So the Java people said you should never be able to do that. Okay. So this is a local variable. This creates a new scope. Okay. Like if I make this 2, print X. Okay. Okay. Notice how at this point I have two X's, one that's in scope and one that's out of scope. When I printed the local, the one those in, well, they were both in scope, but I printed the one that was visible. Yeah. This line here, this X is that X, not that X. So it printed 2. Okay. Then when I get to line 8, one of the X's disappears. See how I have two X's. The one on top is the one that's visible. See, they think of it as a stack of X's. So see, if you had these things nested, the most recent X would be on top. Okay, so the X equals 2 is the one that's being used. Then down here, now I'm back to X equals 0. So I print 0. So I printed 2, then 0. If I did the same thing in JavaScript, well, I can't do that in JavaScript. Down here, I can't create an X that hides that X. I can't have two X's at the same time. Okay, I can do this in Java. It's okay to have a second X afterwards. See, this X goes away right there. So it's okay to have a new X because now there's only one X. First, there's this X, then it goes away. Then there's a second X. It's okay to have two X's, but they can't exist at the same time. Okay. And in Python, in C, yeah, I can have two X's simultaneously, this one and this one simultaneously. All right. And JavaScript is even different. JavaScript is even different than C or Java. JavaScript, even though I could write things that look like this this could roughly be C++ or Java or JavaScript. Yeah, it roughly looks like any one of those three languages, but it doesn't act the same. This code would act differently in all three languages. Declare a variable, declare a variable, declare a variable, declare a variable in a block. Yeah, it's going to act differently in C++, Java, and JavaScript. Okay, all right. So in language 4, whoops, where's language 4? In language 4, begin is what the braces are. So in language 4, I would write something like this as begin, begin, and then instead of saying int x, it'd be var x 10, then var y 0. Then I need another begin. Okay, so the braces are begin blocks. You begin a scope. So begin a scope. A lot of older languages actually use the word begin and end. They would actually have you type begin and end. So there were languages where you would like here we would begin, and then I would say var x y, var y plus x1. Okay, there were languages where you would then type something like end here. Yeah, begin, end. But we don't need the end because the closing brace acts as the end. Okay, so the closing brace acts as enough of an end. We don't need the keyword end. But if you go look at Pascal, a whole bunch of languages use begin end blocks. Okay, so let's see. I'll look at a simple example of Pascal. And those are too small to read. Well, actually, there's this one. Begin, end, begin, end, begin, end. Okay, the C people thought that's a lot of typing. So they changed that to opening brace, closing brace, which was a lot smarter. It just looks way better. And it's, you know, so the one of the innovations in C was instead of you typing begin, end, begin, end, begin, end, you just did open brace, close brace. Okay. In our tree language, open brace and close brace doesn't parse very well. So we're going to use begin without the end. So in our grammar here, you say begin, but there is no end. So the closing parenthesis, the closing parentheses acts as the end. Okay, so this block goes to there, and this block goes to there. Okay, all right. So open closing brace versus begin and closing parentheses. Begin and closing parentheses. So this creates a scope. Now the question is, what should happen inside the scope? What should this do when it's inside the scope? Okay, that's not obvious what there should do when it's inside of a scope. Okay, now let me just save that. Let me show you some examples. I wrote some examples earlier. Okay. Here I'm using kind of the infix notation for our language. A program, this program is var x, print. Okay. Okay. So notice that there's an x here and an x here. And the question is, what should get printed here? Notice here, there's a scope with an x in it, and then you say print x. What should happen? Here, there's x printed before it's declared. Okay. Now, the question is, what should these things do? Okay, let's start with this one. This one's got two possible answers. Okay, this declares a variable. This can either create a new x that hides that x, or it could update that x. And it's not clear. Different languages do this different ways. There's just two choices here, and there's no right choice. This is an x. Okay, then this could either update that x, or it could create a new x inside of this block. Then if you make this a new x inside that block, then that x would go away when it got to the end of the block. So this would print 0. On the other hand, if you think that this should update that x, because that x has already been declared, so this should update it, then this would print 1. Okay, so you can, it's reasonable to print either 0 or 1. This declares a variable. Since the variable's already been declared, this updates it. Okay. Now, down here, this would create a variable local to this. So this probably should be an error, that there is no x. But not all languages work that way. Some languages you could, for example, treat all these x's the same. For example, this brace could be meaningless. You could just say that the begin doesn't do anything. So this x just is that x. Okay, it isn't that this is hiding that x. You can just say that this x is that x, so that guy is printing the same x all along. So this is an x, so go ahead and print it. If you do that, then you really don't have local variables. You only have global variables. There are languages like this, where they have a syntax that looks like local variables, but there really aren't any. Okay. This one's weird. See this one? You would think, whoops, you would think that since there's no x declared yet, that this should give you some kind of error message. Okay. Now, this is a local x, so it shouldn't have anything to do with this one because it's in a different scope. And this x is too late. Okay. So you would think that this should be an error. And to show you that that's not the case, let's look at a simple JavaScript program. Okay. Like here's a little JavaScript program. Okay. I'm using the alert function instead of the print function. So alert. Notice that I'm starting off with just, see, I've got here a print, just like I've got here. See, just print. Okay. Okay. So I've got a print. Okay. So what's this going to do? Okay. If I run this HTML page runs that JavaScript. Okay. So this is a real easy way to run this JavaScript program. If I double click on an HTML page, it loads that JavaScript program. Nothing came out. If I look in the console, I see that I got an error message. X is not defined. Okay. So see, I got an error message. Okay, that makes sense. The X is not defined. All right. But what happens now if I do something like this? Create another X. Okay, watch this. Okay, I'm creating the X after I've used it. Here's the X. Here's after I'm using. I'll make it equal to 5. Okay. Run this. The program's fine. What happens is this X exists, but he doesn't have a value yet. So Java says the value of, actually he does have, he exists and he has a value. This in JavaScript, this X exists. As soon as you name him, he comes into existence. So the fact that I named him makes him come into existence. Well, actually, that's not the right way to describe it. This declared the variable. This declares this is how JavaScript works. This declares the variable. This assigns the value. In JavaScript, declarations are what are called hoisted. So the declaration actually moves up here to line 4. Even though you don't see it, the declaration is at line 4, but not the initialization. So essentially, there's a hidden declaration of X at line 4, but it doesn't have initialization. So at line 5, X is undefined, and then line 6, X gets initialized to 5. Really stupid. JavaScript's a bizarre language. This is called hoisting. So if I comment that line out, this variable's an error. But if I do this, that variable's not an error, it just doesn't have a value yet. It's been declared without a value. Okay. So if down here in JavaScript, this would print undefined because that variable is declared down here. But what about this one? Would this one help that guy? Let's try, let's find out. Okay. So let's close this. Okay. What if I do this? Create a block, put that variable in the block. Okay. Does that help? Is that got anything to do with this X? Yes. Yeah. Yeah. That X is this X, which is local to that block. How the heck that, again, that's JavaScript's weird hoisting rule. That X actually gets hoisted up to line 4. It gets hoisted right out of its inner block up into the outer block. Bizarre. So if we look at this thing here, if this was JavaScript, you don't even know what X that is. Is it this X or is it this one? Okay, let's try going over here and do another version of this one. What if then I put a var X equal 8 here? It's not clear what this is doing. Is this even a new X? Is this X temporarily hiding this X? Is the hoisted one here this one without a definition or this one without a definition? See, what does JavaScript do here? Okay, X is undefined. Okay, and if I go look at the source code, it just, as far as it's concerned, it's perfectly normal. You just don't know. I don't remember the rules of JavaScript well enough to know if that X is actually that one, or if that one, or if they're all, or maybe they're all the same X. JavaScript makes a big muddle out of local variables and scoping rules. JavaScript makes a big muddle. Let me show you how even worse, how bigger muddle I can make of this. If I say X equal 6, notice I didn't use the var keyword. I just said X equals 6. X is 6, okay? Now drop the var from here. So X is 8, right? Now let's see. Oh no, I need to drop both of those X's. Now all of a sudden my X is undefined. X equal 8 and var X equal 8 have different meanings. Okay? This gets hoisted. This doesn't get hoisted. Okay? See, if I put it up here, it doesn't matter if I say var X equal 8 or if I just say X equal 8. They have the same effect. But down here, the hoisting rules are different. So if I say var X here, then that gets hoisted up to here. Or if I say var X here, then that one gets hoisted. But if I do it like this, neither of these are hoisted. They're declared, but they're not hoisted. So then this is undeclared. JavaScript is an example of a language that JavaScript is the model of everything that you can do wrong when you design a language. It really muddles up a lot of things. Okay. Now, the issue here is that when you see this, you don't know what that can possibly mean. Okay. X is, well, or actually a better one is this. You don't know. There's no right, you can't say, well, X is undefined. That's what Java would say. That's what C would say. That's not what JavaScript would say. Well, it depends on whether you use this notation in JavaScript or if you did the var here. If you did the var here, then that guy's fine. He just happens to be undefined. If you do this here, then this guy is undefined, or he's not in existence. Notice that when you do var here, he's defined, but his value is undefined. That's how bad JavaScript is. When you do this, at this line here, that X is defined, but his value is undefined. You couldn't design a language worse than this. The variable is defined. His value is the word undefined. Okay, this is a value in JavaScript. It's like null. It's like a version of the null value. It's a value called undefined. So X is a defined variable with the value undefined. You couldn't make this worse if you tried. It's weird how they ended up stumbling into this kind of a design for the JavaScript language. Okay, now if you do this, then this guy is undefined in the sense that the variable doesn't exist at all. Okay, so now the variable doesn't exist. And you go over here and you look at the console window and you see not defined. Notice not defined, not undefined, it's not defined. Okay, so now you've got a variable that's not defined as opposed to having a variable that is defined, but its value is undefined. Okay, right? Notice that the semantics of languages is tricky. And if people aren't careful, like the JavaScript people, they screwed up royally when they described the semantics of the language. They did not think it through carefully. When you look at code like this, we want to be precise about the semantics of these things. We want to say real carefully what these things do. And we want them to do things that make sense. We want them to, we want them to have we want them to have a meaning that doesn't defy logic like JavaScript does. Okay, right. So over here in language 4 is a description in words of the semantics of this language. What is there going to do for us? And it turns out that there really are two reasonable semantics to this. And you really can't say which one is right. One semantics is this X hides that X. The other semantics is this X updates that X. They're both reasonable. This one hides this one, or this one updates this one. If this one updates this one, then you print 1 here. If this one hides this one, then you print 0 here. The difference between there being an update or there being a hiding, it's really not hard to, it's really hard, there's really no rule about how you should do that. Now, this creates a new Y, okay? Now, then one semantics is that creates a new X that hides that X, and this creates a new Y. The other semantics is this updates that X, and this creates a new Y that's local to this block, okay? So this, since there is no Y to update, this creates a new Y, but a local one. Since there already is an X, we have to make a decision. Should that X update the one that already exists, or should that X create a new X that's local to this block, and then that X goes away and you're back to this X when you leave the block. This Y goes away when you leave the block, so down here, you shouldn't be able to print Y. If you print Y down here, that should be an error. In our language, that will be an error, that this Y goes out of scope there. This X, well, we have to decide if this X updates that X, then it doesn't go out of scope because this X stays in scope till there. If this X creates a new X, the new X goes out of scope there. Okay, so we have to make a decision about our language. How should var work? Should var update an existing variable or create a new variable? Okay, so in the description of the semantics, I give 2 semantics for this language. The interpreter, there's 1 line of code you change the change between the 2 semantics. In the two different semantics are the difference in 1 line of code out of, if you look at the interpreter, that's this evaluate guy. The interpreter is all of almost 600 lines of code. The 2 different semantics are changed by only 1 single line of code. We'll change the 2 semantics. There's just 1 line of code in here. We'll see where it is in a minute. There's just 1 line of code in here that changes between the 2 semantics. Okay. So now default semantics I gave it is the one that's more like Java. Okay, so by default, I set it so that this creates a new variable that hides that one. Okay, that's the evaluate the way it's written right now. It acts like C. Well, it doesn't act like Java. Java doesn't let you have a local variable hide a local variable. So right now, the default behavior of evaluate is like C. This one hides that one. Then when you get to the end of the block, this one goes out of scope and you're back to that one. And you cannot have a variable that's not been defined. Okay, so in our version, the default version of the language, this prints 0. But then if you change that one line of code, you can give it the other semantics and that'll print 1. Okay, in our version of the language, that's an error. So we're not going to be JavaScript like. So that would be an error. There is no X in scope in this block. This X went out of scope there, so there's no X in scope here. So that'll be an error. Okay. In our language, this will be an error because there's no X in scope. This X goes out of scope there. This X goes out of scope there. So there's no X in play at this line. So this X lives in lines 26 and 27. And this X lives in lines 28 and 29. And there's no X here. So that's an error. And then this will be an error. Okay. But notice that the reason I did all these examples is because JavaScript is the exception where this stuff's weird. Like, okay, that's an error in JavaScript. There is no X. But that's not an error in JavaScript. Well, it might be or it might not be depending on exactly how you declare X. Yeah, depending on how you declare the X, the X might get hoisted, and so this guy might actually exist. Okay. Again, same thing true in here in JavaScript. Depending on how you declare this X, it might have been hoisted up to here so that it would exist down here. Okay. So if you declare this X in a certain way, if you declare it one way, it's local here, and then this X doesn't exist. But if you declare it a different way, then it gets hoisted up to here, and then it becomes that X there. Okay, so JavaScript is the weird language. Same here. This guy could be that guy, or this guy could be his own X. So this X could be 0 or it could be 1. You know, in JavaScript, you have to look at the details of how you wrote the code to know whether this X is 0 or 1. Okay. So these examples, if you're a C programmer or a Java programmer, all of these seem silly because you're using the variable without declaring it. Yeah, clearly there is no X in scope. There is no X in scope. There is no X in scope. But JavaScript is the weird language. It's the one that you have to be very careful with because it's got such odd scoping rules. Okay. Okay. So now there's two things we have to describe how this language acts. We have to describe. We got to describe what begin does and what var does. Var is carried over from language 3, but it acts different in language 4. So we have to say how var has been changed, and var is going to act in one of two different ways. You know, we're going to end up giving var two different semantics. Okay, and then the question is, what does begin do? Now, to give you an example of what begin does, let me run the interpreter. The interpreter is meant to show you. Oh, I clicked on the wrong one. The interpreter is kind of meant to be like the visualizer. It tries to visualize things. Like, you know, when we ran the visualizer, either the JavaScript the visualizer, no, I'm sorry. Where did the visualizers go? The visualizer tries to show you pictures over here of the variables. Okay. And over here, the visualizer shows you pictures of the variables. That's the environment. See, the environment is where the variables live. So this is the environment. The environment's divided up between a stack and a heap. Same in Java. The environment is divided up between a stack and a heap. Okay. In our language, we have a simpler notion of environment. We don't have a stack and a heap. We just have an environment. But the interpreter over here is trying to visualize things for you. So if I say var x 0, I see that I have the global environment with x in it. Okay. Okay. So I've got the global environment with x in it. And then if I do var y 1, I put 2 things in the global environment. Okay, now if I say begin, what begin does is it creates a new environment that's temporary. So begin now var x4. That created a local environment that held an x that hid the x in the global environment. See, there were 2 environments now, but what we're going to think of is that this is actually a linked list. This is one environment linked to another environment. Okay, now here's why I want to have a environment with linked list. Suppose I do, let's see, I'll have a, begin var x5. Now I create a local x. Now I say multiply x and y. This, well, that x is the local x, but that y is going to be the y in the global environment. Okay, so what the interpreter is going to do is, when it gets to this expression, it'll look for x in the local environment and find it. Then it'll look for y in the local environment. It's not there. So then it follows the linked list from the local environment to the global environment and looks for y again and finds it. Okay, so the interpreter, when it looked for x, it looked in the local environment. It's a linked list. It found x, fine. Then it looked for y. It's not in the local environment. Follow the chain. Oh, it found a y in the global environment. Okay, like let's do a more complicated example. Begin var x5, begin var y2, take the product of x and y, okay, close one begin block, close the other begin block. Now what the interpreter is going to do, creates this begin, creates a local environment with an x. This begin creates another local environment with a y. Then you multiply x and y. You look for x in the local environment. It's not there. So you follow the linked list and find it in this environment. Then you look for the y in the local environment and you find it. Oh, this one doesn't use the global environment. Okay, well, in a minute, let's do one. Okay. The output's kind of, because it's static and not a GUI, the output's a little bit tricky to read. When you interpreted this expression, first you created this local environment with an x linked to the global environment. That was this begin var. But then when you got to this begin var, then you had this local environment with a y chained to this local environment with an x chained to the global environment. So this chain was up to that piece of code there. Okay, then this chain was up to there. Okay, every begin adds to the length of the chain. Okay, so this created a 2-link chain, and then this created a 3-link chain, and then XY was evaluated in the 3-link chain. Okay, now let's do a more elaborate example. Var z, say 7. Okay, z is in the global environment. Now I can do y will be found in the local environment. X will be found one step over in the previous local environment, and Z will be found 2 steps over in the global environment. Okay, so then execute that. Okay, then here's the last chain. Here's the local environment with Y, pointing at the local environment with X, pointing with the global environment with an X, Y, and a Z. That X hides that X. This Y hides that Y. So this Y is hiding that Y. This X is hiding that X. When you evaluated X times Y times Z, You had to start in the local environment. There's a Y, fine. No X, follow the link. Oh, we found X, but no Z, follow the link. We found a Z. Okay. Now we don't look for X down here because we found X up here. And we don't look for Y down here. That's why it's a linked list with the most local environment first. Okay. Yeah, if we wrote that in a more traditional notation, it would look something like this. We have a global variable X. Let's see. X is 0 in the global environment. Y is 1 in the global environment. Z is 7 in the global environment. Now I create a block. In that block, I have X is 5. Then I create another block. And in that block, I have Y is, what I do? Y is 2. And then I evaluated X plus Y plus Z. Close that block. Close that block. Okay. All right. So this X, you look, it's not in this scope. Oh, but it's in this scope. So that's what X is. You stop there. That's how Java would do it. You would stop there. This Y, right there. So you stop there. You don't go up to that one. This Z, well, it's not in this scope. It's not in this scope, but it's in the global scope. And if you want, you could put the global scope in another pair of braces. Depends on your language. C allows you to have a global, the C language allows what we just had. C allows something like that. Java doesn't. In Java, everything's sitting inside of braces. Okay, so if we thought Java like everything's sitting inside of a class file, so everything is sitting inside of braces. In C, things sit in the file, and there doesn't have to be braces at the top level of the file. So C can look like this, so can JavaScript. But Java can't look like this. There can't be anything at the top level except a class. So you have to, so everything's got to be inside of some kind of pair of braces. Okay, so this would be more Java-like. This would be more C-like. Okay, but this can't be Java-like either because Java doesn't let this guy hide that guy. So this is not Java-like either. Local variables can't hide local variables, but local variables can hide instance variables. Okay, so if this is a static variable, if these are static Java variables, then this local variable can hide that static variable, and this local variable can hide that static variable, and then this could work. So if I did this as static here in Java, then this would make sense. That's a static variable in the class. That would be a static variable in the class. This one would be a static variable in the class. This local variable can hide the static variable. This local variable can hide the static variable. Okay, so in Java, it could look like that. But everything has to be inside of a pair of braces. Okay. Okay. So we're trying to understand exactly what braces mean, what we call scope. What is the scope in your language? Braces by themselves don't have any inherent meaning. Just writing that doesn't tell you what it means because C does one thing, Java does another thing, JavaScript does another thing. Our language can decide, we're allowed to decide what our language does. It's up to us to decide what the language does. Right now, that is creating a new variable that overrides that hides that variable. Okay, right now the interpreter, this hides that, this hides that. But I could change the interpreter by changing one line of code, and then this would update that. This would update that. Okay. All right. All right. So now let's look at the interpreter. So now the important point is that a brace creates a new environment, and the environments are chained to each other, okay? So one thing we need to see is that now the environment class is like a linked list. Environment object holds a list of variables, a list of values, and a link to another environment object. So an environment object holds a link to another environment object. And I call it the non-local link because it lets you look up variables that are not local variables. You use the link to move from the local variables, which is y, to a non-local variable. See, it's not local to that block. In this block, if you want to look up z, you have to look outside of the block because z is not local. So in this picture here, the link, that link there, that's the link that lets you go to say what's local, what's non-local. So in this local environment, it only holds y. Then there's the link to what are not local to relative to this block. You get another local block, and then another link to things that are not local to it. Then eventually you hit the global variables. Okay. But each environment just points to the next. Each environment says, if you can't find something in me, go look here. If you can't find something in me, go look here. And when you hit the global variable, if you don't find something there, you throw an error. If you can't find it by the time you get to the global variable, the variable doesn't exist. Okay, so the environment object now holds a reference to the environment objects form a linked list of environments. Okay, and then when you look up something, there's a new sense of looking it up. You can look up a variable in the local environment, or you could look it up in the whole chain. So for example, here is a chain of 3 environments. A local pointing to a local pointing to global. In here, I can look up y and ask, is it local? And I can look up x here and say, is x local? And later on, we'll see that I want to know the difference between x being local and x being not local. So I want to be able to look up variable only in the link at the head of the linked list. So define local means in the head of the linked list, in the environment that's the head of the linked list. Whereas lookup looks anywhere in the linked list. Turns out we need these 2 different notions of lookup. Okay, lookup locally and lookup globally. Okay, but gotta be careful. Don't call it global because this is the global environment. This really means look it up in the whole chain of environments. Look to see if it's anywhere in the chain. So in this chain here, if I looked up x defined local, I'd get false. Defined local, no, x is not defined locally. But if I call lookup, x is in the chain because it's in the middle. Okay. If I look up y locally, yes, it's right there. And if I look it up globally, or if I look it up in the whole chain, I'll get back this one too. This one finds the first instance of that. It doesn't find all of them. It only wants to find the first one. So if you look up y this way, you'll get back that answer. And if you look up y this way, you'll get back that answer. If you look up x this way, you'll get that answer. If you look up x this way, you'll get false for x not being defined because x is not defined in that local environment. Okay. And if you look up z here, you'll get that z doesn't exist. And if you look up z this way, you'll get the z that's in here. You'll get that z. Okay. So the environment's changed in 2 ways. It's got a new sense of lookup. It's got a distinction between local lookup and the whole environment lookup. And it's a linked list of environments. So the environment is now a linked list. Okay. All right. And then the other thing we want to see is that the evaluator, we need to ask, how does it evaluate begin, and how does it evaluate var? Okay, so now the syntax for begin is the word begin and then any number of expressions. Notice that's a lot like prog. Prog was the word program followed by any number of expressions. Notice that, remember, this was there to let us sequence expressions. So we can say, let x be 5, let y be 3, let z be 4, now take their addition. This was there for sequencing purposes. Begin has actually now got two uses. It sequences expressions, but it also creates a local environment. And this is true in Java. The braces actually do two things for you. Whoops. In the Java language, we actually think of braces as doing two things for us. Remember, in Java, if you say if something, you can do okay? On the other hand, you could do the following. Now, you could put braces there. Now, when you put the braces there, people tend to think that they're there so you could do multiple statements inside of the else and the if clause. But in fact, the braces do two things. Like you can't say do something one, do something two. Okay, that's broken Java. You'll get a compiler error. Okay, here you can say do something one, and then you can say, now you can sequence. You can do something two. So you can do sequencing. The braces let you do sequencing, but the braces also create a new block for scope. Especially a lot of beginning Java programmers don't realize that the braces do two things for them. They let you sequence and they give you a local scope. And that's how our interpreter is going to work. The begin block does two things. It lets you sequence, but it also creates a scope, a new environment. It creates a local environment. Okay. But and Java and C all work that way. The braces do two things for you. They create local scopes, but they also let you sequence. Okay. Now Python's a different language. Like this would be valid Python, because Python uses indentation. But if it uses indentation for sequencing, what does it use for scoping? And the answer is Python's screwed up. Python has trouble with scoping. Java lets the brace do two things: create a scope and create a sequencing. Python, they use indentation for sequencing. I don't remember if they create a scope here. I don't think they do. I know Python has trouble with the notion of scope. That's been a controversial fact about Python. It doesn't do scope in a really clear way. Okay. Once you're used to Java, you realize that braces do two things. They create the scopes and they let you do sequencing. So if you want to do only one something here, you don't need the braces, because you don't need this. Here, there's no scope. There's no scope for a local variable there, and there's no braces, and there's no sequencing either.
Professor?
Yeah.
Scope is also handled by indentations.
Is it? They do it,
Yeah.
So it does create a new block of variables?
Yeah, so if you wanted, for instance, a second if after the first one, you would indent it, like if you put it in between the if and the else.
Yeah, but that's not
would,
scope. That's
but it would be its own new.
But see, that's not scope. That's just sequencing. That's still sequencing. Scoping is when you would say you would have a variable x at height. Scoping is when I have x equal 5 here, and down here I say x equal 6. And is that a new x or is that an old x?
I don't want to be wrong. I would have to test it.
Yeah, me too. See, I don't remember. I do know that Python controversially doesn't do scope really clearly. I don't know if indentation creates a new scope or not. But I do know for sure that Python doesn't handle scope as clearly as people wish it did. JavaScript clearly screws up scope, and Python also doesn't quite do it right as far as but I don't remember the exact rules in Python. So I don't know if that creates a new scope. The idea of putting a new if in there, that's more sequencing. See, that's just doing more sequencing.
Gotcha.
Okay. All right. So you can't put two if statements in there. Well, in Python you can, but in Java, see, in Java you can do this. Yeah, you can have an if instead of an if without the braces, but that's not. Then there's no new scope there. There's no scope there. There's just sequencing. Okay. Okay. So our begin block is going to be both sequencing, and that's here in the grammar, and it also will create, which is not obvious in the grammar, when you do a begin, you create a new environment, okay? The return value of a begin expression is the last of these expressions. So that's just like the program. The value of the program is the last expression. The other expressions are there for their side effects. Same thing here. The last expression is the return value of this begin. All the other expressions are there for their side effects. They could either print things or they could declare more variables, but those are side effects. Okay. Now, if we go look at the evaluator, here's evaluate begin. Okay. It creates a new environment linked to the previous environment. See, here's the environment that it was given. That's whatever current environment's in use. That might be a chain of environments. So right now you have to think of this as the head of a linked list of environments. Okay, in the language 3, this was always the global environment. In language 4, this is the link to the head node of a linked list of environments. And right here, I'm adding a new node to the front of the list. Okay, so that over here in this picture, that would take, see, here's a link of 2 nodes. And then that would be created by the first begin. This inner begin takes that link, that chain, and adds that to the front of it. See, that would be this line of code here. That line of code there added an environment to the front of the chain. Okay, right? So, and then after you create this new environment at the front of the chain, then you evaluate all the expressions except for the last one. You evaluate all of them except for the last one and you throw away their results. But you evaluate the last one by itself because that's the return value. So in the syntax, all these expressions except for the last one are evaluated and the results are thrown away. Then the very last one is the return value for the begin expression. Okay, so here's the for loop that iterates through all but the last branch of the tree. See, it stops and doesn't do the last branch of the tree. It throws away the results of every evaluation. So it's only evaluating things for their side effect. Then when it gets to the last tree, it saves the result. And then that's when it returns. And when it returns, this local environment, which is a local variable in Java, gets garbage collected. See, when this thing returns, one important thing to realize is that local environment that was at the head of the list, it's just garbage collected because it was a local variable in this function. So you're back then, when this thing returns, you're back to this chain here without this, this thing gets popped off that chain and you're back to this one here, which is this one over here. Okay, So when you return from this function, you lose the head of the node, the head of the list that you created here. Okay, so that's what begin does. Now the question is, what does var do? Okay, what does the var command do? In language 3, var added something to the global environment, or it updated something in the global environment. Okay. In language 3, if a variable existed, you were updating it in the global environment. If a variable didn't exist, you put it in the global environment. Okay. So every time you saw var, you would just check, is it already in the environment? If so, update it. If it's not in the environment, add it to the environment. Okay. Now, in our language 4, we said there's actually two different semantics to the var. Let me get back to that example. In this example here, we can think of that line as doing one of two things. One possibility is it creates an X in the local environment that hides that X in the previous environment. Or we could say this X updates that X in the previous environment. And then this Y creates a Y in the local environment. So we could say that if the X exists, update it. If the X doesn't exist, create it in the local environment. Now that's very similar to the previous language 3. Language 3, var X either updated already existing X or it created a new X. Now the question is, do I always create a new X? Or should I update a pre-existing X and only create a new X when there isn't a pre-existing X? But I always create the new X in the local environment. Okay, so let's look at the two different ways of doing that. Yeah, we can implement either of those semantics, and different language. There are languages that do both ways. If you look enough through the history of programming languages, you'll find a language that says this thing should update this one, and you'll find a language that says this thing should be a new X that hides this one. You'll find both kinds of languages. Okay. In our evaluator, the difference is in evaluate var. Okay. First of all, var looks to see it has two branches. There shouldn't be less or more. Var needs exactly two branches. Okay. So first check that there's two branches. The left branch is the variable. So you grab the left branch and check that it's a proper variable name. Okay. So if I go back over here, remember my interpreter, if I say something like var 3445, improper variable name 34. See, 34 is not a proper variable name. Or if I say something like var underscore 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 x 45, that's not a proper variable name. Okay, so I have to have a proper variable name. A proper variable name would be like x4 is a proper variable name. Okay, so or another example is if I say var x, wrong number of arguments for var. I can't declare a variable without giving it a value. Or if I say var x45, improper number of arguments. There shouldn't be two values for x. Okay, so the evaluate var checks that there's two arguments, grabs the left argument, makes sure it's a variable name. So all that's runtime checking. Okay, now it grabs the right-hand expression. Okay, so it evaluates the right-hand expression. Okay. Now the question is, what should it do with the right-hand expression? Okay. So it's evaluated the var, say z. Do I have a z? Yeah. Var w plus x y 17. Okay. So you check that that's really a variable name. Then you evaluate that expression to whatever result it is. So now you've got a variable name and a result. Okay, so we've got a variable name and a result. Question now is what to do. Okay, and the two questions are, does that variable exist already or not? Okay, so one possibility is we just take the value and the variable and put it in the local environment. So one possibility is we just immediately put the local variable in the local environment. The other possibility is that we ask, does the variable exist already? Because if it exists already, we should update it. Okay, so there's two possible semantics. One is just put the value and variable in the local variable, put the value and the variable in the local environment. And the other possibility is ask, does the variable already exist? If so, update it. Okay. Okay. So now, there's actually a third possibility. If we go over here, there's actually a third possibility. This one, it's already, this one here could either update this one or update this one. See, this one could either update this one or create a new variable, but definitely down here, you've got an X already. It's either this one or this one. If this one created a new variable, this one should update it. If this one updated that variable, then so should that one. So if this one created a new variable, this should update the new variable. If this one updated the previous variable, then this one should update the previous variable. So there's really, there's several different cases so we could already have a local X, in which case we update the local X, but we may not have a local X, in which case we either create a new local X or we update the pre-existing X. Okay, so that's handled in this logic here. Okay. If the variable is not defined locally, if it's not defined locally, we add it locally. Okay, so that's creating a new variable. That's what okay. If it is defined locally, we update it locally. Okay, so if it's not local, create it local. If it is local, update it local. Now here it says change that from defined local to defined. Okay, now suppose I change it this way. Now it's the other semantics. Okay, now is if it's not been defined anywhere, add it locally. If it's been defined somewhere, update the one that's been defined. See how that you change this from that to that, and you get the two different semantics. Okay, with this semantics, if it's not local, create it local. If it is local, update it local. In this other one, if it's not in existence anywhere, create it locally. If it does exist somewhere, update it wherever it is. So that's the other semantics. So you only need to change one variable, you change one little thing, and you've got these two different semantics. And that actually are real programming languages. You're really talking about different programming languages. Notice that it's subtle little things in your code can change the language semantics in interesting ways. Okay, so you get two different semantics by just this one line of code here. The default was this one. So this is the one that's more Java-like and C++-like. So that's the one that says this creates a new X in the local environment. This updates that X in the local environment. Okay, so that's the default behavior. That's the one that evaluate is written as. But then, change that guy to that guy, and then it becomes the other semantics. Okay, and then everything else in this interpreter is exactly like language 3. So the only difference between language 3 and language 4 is there's that change in var, there's this new begin, and the environment itself is a linked list now. The environment is a linked list. And it's got this new method that lets you ask, is the variable local? Or is it been defined. Yeah, this is just that. This just says, is the variable in existence anywhere? This says, is the variable local? And see, that's where we used it. See, that's where we used it, was here. We needed to know whether the variable in evaluate var, we needed to know, is it defined locally or is it defined anywhere? See, defined anywhere, defined locally. So we need those two distinctions in the environment interface so that we can give our language two different semantics. Okay. All right. Then, so that's all, everything. That's all language 4. We haven't started language 5. Language 5 makes things more Java and C++ like. There's something missing here that's not very elegant. Okay, and we'll talk about it. This is the way language 4 acts is pretty sloppy. You know, you wouldn't design a language like language 4. We'll see what I mean by that on Wednesday. So language 5 is going to clean things up and make things more like Java and C++. But the thing about language 4 is it acts a lot like JavaScript. JavaScript's just a real weird language. So language 4 is actually kind of close to JavaScript's weird way of being. Okay. So language 4 is a kind of, the reason I designed language 4 is, for one thing, is it's real interesting that a tiny change in the interpreter can give you two different semantics. Language 5 doesn't have two different semantics. Language 5 kind of has a clear semantic, the syntax almost dictates the semantics. But language 4 is interesting because the syntax doesn't dictate the semantics. The syntax leaves things kind of vague. So we have this, what does that line there do? It's not obvious whether it should be updating this guy or hiding that guy. And in the history of programming languages, both interpretations were used, update or, okay. So we'll see how we can make this more clear in language 5. Language 5 will be closer to modern programming languages. Okay. All right. And then when we get to language 6, we'll start adding if statements and while loops. We haven't got any control flow yet. We've only got expressions and variables, and we've got block scope. We've got block scope, but we haven't got control variables yet. We haven't got, language 6 will then add control, and then language 7 will add functions. And then we're really have language 7 will have a programming language. Okay. When we have scope, control flow, and functions, we really have a real programming language. You can actually write, sorting methods and all kinds. You could write recursive functions. You can do all kinds. By the time we get to language 7, you can do all kinds of programming. Okay, you can't do much programming yet because you don't have flow control. So language 4 is not Turing complete, and language 5 won't be Turing complete. Language 6 may or may, I'm not even sure if language 6 is Turing complete or not. Can you write any program you want in language 6? I'm not sure. But language 7 is. Language 7 is a real programming language. Okay, so we'll quit here. Okay. And then, so on Wednesday, we'll do language 5. We'll see how we refine scoping and make it more modern. So we'll and actually, the refined scoping is called lexical scoping. Okay, so you may have heard that term. What we're going to do is we're going to refine the scoping to create what's referred to as lexical scope. What we have now is kind of a screwed up lexical scope. So we'll get a more precise form of lexical scope in language 5. Okay, so we'll quit there, and I'm going to stop sharing. If you have questions, come to office hours tomorrow or send me an email. And especially, right now you have assignment 2, which is you modifying language 3. Okay, so if you have questions about that, send me emails or come to office hours. Okay, so see you on Wednesday. Bye.